Good evening, everyone. It's Dr. Sheptall again with Truth in Science. I'll tell you, tonight we're going to have an amazing presentation. It's going to blow you away. I just finished an operation this afternoon with a young protege of mine who I met 20 years ago, and he left Cambodia to go to France to learn how to be a neurosurgeon, and we just did an operation today that took more than 4 hours, but he did a tremendous job, and I'm very proud of him. I just wanted to start off with that. Okay, so tonight's presentation is going to be entitled Hydroxychloroquine Revisited, and I hope you can hang in there for the entirety of this because it's really going to be shocking in a lot of ways. So let's get started. Again, this is the bona fides page, which we'll skip. But I would appreciate it if everyone would go to my Patreon page and consider becoming a patron so I can keep doing these presentations. All right. I did a presentation recently on vitamin D. And after rejecting a study from Sao Paulo, a randomized controlled trial, because the type of vitamin D that they had administered to the patients took too long to get to its active form in the tissues, I found another randomized controlled trial that was done in Cordoba, Spain, which used a metabolite of the type of vitamin D that you take from the drugstore called 25-hydroxy vitamin D. And this gets to the tissues very quickly and showed the tremendous benefits of vitamin D. And as I was presenting that study to everyone, because remember, vitamin D had enormous support in associative studies, but we needed to find randomized controlled trials because that's really the way that you prove that something works. And I presented this Cordoba study, which used 25-hydroxy vitamin D. And while I was presenting the study, I was showing that the patients had been matched for the rest of their treatment. And they were all receiving hydroxychloroquine and azithromycin. And this study was in September, was presented in September. So I'm thinking, hydroxychloroquine, that was the medicine that all of the TV doctors had said had no benefit whatsoever. And all the anchors on CNN literally every day through the spring and summer said this. And I was amazed to find out that it was considered the best available therapy by the doctors in Spain. And that's why I wrote, you can't make this stuff up at the bottom. So while I was presenting this, I told everyone that I would be glad to look it up and look into the studies that the TV doctors had said proved that it didn't work. And so many people asked me to indeed do that I did. And that's what I'm presenting tonight. So let's look at hydroxychloroquine again. Let's revisit hydroxychloroquine because some studies have been done recently that are going to blow your socks off. It's a safer version of chloroquine. It's used to treat systemic lupus erythematosus, rheumatoid arthritis, and juvenile idiopathic arthritis. These are autoimmune diseases, and hydroxychloroquine is known to modulate the immune response, to downregulate it. And of course, that's what you want to do with an autoimmune disease, because you don't want your immune system to attack your own tissues, which is what occurs in lupus, rheumatoid arthritis, etc. They're autoimmune diseases. Hydroxychloroquine is also used as a prophylactic and a treatment against malaria. A prophylactic is something that you take before you get the disease to help prevent you getting it and to start treating it if it were to get inside your body. And let me just say something about a prophylactic. A lot of the TV doctors, again, and the CNN anchors said that hydroxychloroquine was a very dangerous drug and caused all these problems and so forth in the studies. The reason for that was that they used doses which were way too high, which we'll talk about in a second. In some cases, triple the recommended dose. But the FDA doesn't recommend medicines for use as prophylactics if they're dangerous and could even cause death, because they're prophylactics. You haven't even gotten the disease yet. Can you imagine recommending something as a prophylactic, which was more dangerous than the disease itself? So that doesn't happen. That's evidence that something was a little bit awry there to say that it was a dangerous drug. It's also been approved for use for 65 plus years. Okay. Now, hydroxychloroquine can also be used in pregnant women with systemic lupus erythematosus without causing fetal abnormalities. It reduces the chance of blood clots, which is important in SARS-2 also. It reduces the amount of steroids needed to keep SLE and rheumatoid arthritis under control. And that's very important because steroids have a lot of deleterious effects. And it very importantly, and germane to the presentation I'm doing tonight, is that it acts as an ionophore for zinc. Let's talk about the side effects. Of course, they're very important as always. 90% of patients who take hydroxychloroquine experience no side effects. But some people get dry skin, rash, loss of appetite, headaches, and muscle aches. There is a generally reversible damage to the retina that can occur, or that occurs, in 1 out of 5,000 patients who take hydroxychloroquine for 5 years or more. So this is completely irrelevant to its use in SARS-2 because you're not going to be taking it for 5 years or more. You might take it for 2 weeks or a month because by then the SARS-2 has been cured, okay, or done its dirty work. So there's no reason to take it longer than that. Hydroxychloroquine lengthens the QT interval on the ECG. That's the pointed graph shape that you see when you see someone's heart beating on a monitor. And it does cause very rare cardiac arrhythmias. So that is true. And there have been people that have died of it, but it's extremely rare. This is a very safe medicine. Okay. Now, here's where the controversy started. Hydroxychloroquine and SARS-2. Numerous doctors working in an outpatient setting, I'm talking about in their clinics, in the real world, seeing patients, claimed and still claim that hydroxychloroquine, zinc, and azithromycin are effective in markedly reducing hospitalization and death when given to a specific group of patients. These are high-risk patients who are treated early in their course of the disease, okay? These are people that came to their clinic. They were not in the hospital yet, okay? This is early in the disease. A number of TEV doctors listed here, and all the other CNN doctors and CNN anchors have claimed repeatedly that hydroxychloroquine plus or minus zinc and azithromycin are ineffective against SARS-2 and are dangerous. Now, the reason I keep mentioning the CNN anchors is because, you know, most of them are journalism majors or communications majors. They don't know anything about medicine, but they keep weighing in on medical topics. For example, one of the anchors on CNN, when the controversy about dying with COVID or because of COVID was at its peak, said that all of the people with heart disease would have survived the whole year if they hadn't gotten COVID, trying to prove that COVID was the reason they died and not the heart disease when they had both. But I'm studying cardiac surgery now, and 90% of patients with advanced cardiac disease die within 1 year. What that means is that even if they hadn't gotten COVID, that group of patients, 90% of them would have died within 1 year. And she said 0%. Good Lord. Okay. But things like that are said all the time by the CNN anchors, things that make absolutely no medical sense. So if they're going to step out and make comments like that, then they're going to be held responsible for them to some degree. Okay. Now, there was a study from Detroit. Remember, I'm just trying to find out if hydroxychloroquine works. I've said many times, I don't know if it works, but I don't think it was treated fairly in the medical community, because I'm going to talk about some studies that were done. And you're going to probably agree with me that it was not scientifically studied. But in one place that it was studied and a paper was presented, I rejected the study. And it was in favor of the efficacy of hydroxychloroquine. I rejected it because some of the patients in the study, not all, had also gotten dexamethasone, and it was a hospital study. And we already know that corticosteroids like dexamethasone reduce death in critically ill COVID patients, okay? And since they hadn't matched the groups for dexamethasone use, I rejected this study, okay? All right. So again, I'm rejecting a study that's in favor of using hydroxychloroquine. I'm not trying to prove a point here. I'm just presenting studies that have come out recently. Now, does triple therapy work? That's the question. The TV doctors and the bureaucratic doctors have used as their justification that it does not work numerous studies, and I mean the internet is full of them, including 6 primary ones that they frequently quote as being the ones that prove that hydroxychloroquine does not work. The problem is that none of these 6 studies, or others that I found, not a single one, looked for efficacy in the group of patients claimed to benefit. In other words, they looked at ill patients in the hospital instead of high-risk patients in an ambulatory setting in someone's clinic, okay? Several dosages were used that were triple the recommended dose, which caused a lot of side effects, making it look like hydroxychloroquine was dangerous. In a fair number of the studies, they used way too high a dosage. None of them used zinc. Zinc is part of the triple antibiotic therapy, and the studies didn't include zinc. Finally, as I said before, they studied hospitalized patients, some of which were very ill already. And when I talk about the mechanism of action of hydroxychloroquine, you're going to see that the stage in which you give the medicine is very important based on what it does. Okay? Let me just say now, because it might be something that you don't quite absorb, and if you hear it a couple times, you'll understand it. Hydroxychloroquine prevents T cells from being activated. And if you've watched my primers in my previous videos, the activated T cell is the entity that releases cytokines. And some of the patients in SARS are thought to have died because of a cytokine storm, okay? So if you get a critically ill patient and give them hydroxychloroquine, a critically ill patient being someone who's already got fluid in their lungs, blocking the cytokine release, it may be too late for that because it's already been released and caused all this fluid to accumulate in their lungs, okay? But if you catch them really early and block cytokine release, as in an ambulatory patient, it may do a lot more good. Okay, so we'll repeat that a couple times so you get that. All right. First study I found that contradicted the large number of other studies where they hadn't set the studies up correctly because they didn't use zinc, or they used too high a dose of hydroxychloroquine, or they used it in sick patients in the hospital, was a study done by researchers at New York University Grossman School of Medicine. They looked at 932 coronavirus patients hospitalized now. These patients were hospitalized between March 2nd and April 5th. The triple drug combo of hydroxychloroquine, azithromycin, and zinc improved coronavirus patients' chances of being discharged and cut death risk by almost 50%, okay? Cut death risk by 50%, okay. Half of the patients in the study were given hydroxychloroquine, azithromycin, and zinc, and the other half did not include zinc. So what they're comparing there was how much improvement they got by adding zinc to the mixture, and they reduced death risk by almost 50%. Remember, a lot of this, not a lot, all of the studies that I could find quoted by the TV doctors did not use zinc. But zinc was a component of the cocktail that was claimed to work by the clinical doctors, okay? Patients receiving the triple drug combination were 1.5 times more likely to recover enough to be discharged and 44% less likely to die. And the team believed that hydroxychloroquine helps zinc, which has antiviral properties, which we'll talk about in a second, get into the infected cells. And I'll show you how that works in the mechanism of action slide. Now, here was the study that actually looked at the group of patients that were claimed to benefit by this triple therapy cocktail, if you will. And this study was done at Baylor University Medical Center, Baylor Heart and Vascular Institute. And they had 2 periods, period 1 and period 2, which I'm going to talk about. They studied a total of 869 patients. That's a lot of patients. Okay. Now, this is a busy slide, but it's very important because it talks about, it's a flow chart for patients in that group. And they compared patients less than 50 years old and healthy, patients greater than 50 years old with greater than or equal to 1 comorbidity. And those are the high-risk patients now. That's why this study is so relevant. So let me put my glasses on so I don't make a mistake in reading this. And we're going to go over this just a little bit. I won't let it last too long, I promise. Age 50 or greater, or a single comorbidity, body mass index greater than 30. Now that means someone who's overweight, pulmonary disease, diabetes, cardiovascular disease, chronic kidney disease, cancer, that's the comorbidity there. With a single one of these though, okay? They got a nutraceutical bundle of zinc, vitamin D, vitamin C, etc. Okay. Now, here were the agents they were treated with. Greater than or equal to 2 anti-infective agents. Hydroxychloroquine, azithromycin, or doxycycline, that's another antibiotic. Remember, zinc was in the nutraceutical bundle. So this is the group that got hydroxychloroquine, zinc, and azithromycin. This group got ivermectin, which is another drug that I'm going to talk about in just a second. It's an anti-parasitic drug that's in the news a lot. Azithromycin or doxycycline. And of course, it got also the nutraceutical bundle. And over here, we have an antiviral that I'm not familiar with, okay? But you had 3 groups here. All right. These are patients, respiratory symptoms or day 5 of illness. This is very early in their course. Those patients got an inhaler to help them breathe, and they got dexamethasone. All right. Now, I'm going to talk about the results of this study in just a second, okay? But I just wanted to show you there's groups of patients here that hadn't been studied for this walk-in group. Remember, these are patients who had COVID-like or COVID-19 confirmed illness, self-quarantine at home. They went through these things like contact tracing and stuff. But they walked into the outpatient clinic there at Baylor. Okay. Now, because we mentioned hydroxychloroquine, zinc, and ivermectin, I want to show you the mechanism of action of these things. Now, this is busy, and I'm not going to talk about everything in this slide, but you'd be surprised how much of this you already know because you studied the immunology primer that I gave in some of my other videos. So let me just go over this very quickly because I want to show you what hydroxychloroquine is thought to do. It blocks the immunological response and the viral replication in a number of areas. And let me just very quickly go over this. Number one, it blocks binding of the virus to the ACE2 receptor. Number two, it blocks the sialic acid ACE2 receptor combination that benefits entry of the virus into the cell. When the virus gets endocytosed into the cell, number three here, as a mechanism of action of hydroxychloroquine, it blocks this endocytosis from becoming a viable endosome with the proper pH. It actually raises the pH too high for this to work. But if it is able to release some of the messenger RNA, okay, that messenger RNA will hijack a ribosome in the cytosol of the cytoplasm of the infected cell and make the proteins like I talked about in the other primers. Those proteins will be processed through the endoplasmic reticulum and the Golgi apparatus to package a new viral particle into an endosome, which will eventually fuse, its cell wall will fuse with the cell wall and release the virus into the interstitial space. But hydroxychloroquine blocks the assembly and budding from the Golgi apparatus, okay? It also blocks, number 6 here, lysosomes from combining with the autophagosome, okay, which contains proteins synthesized or translated from the viral RNA, which are broken up in this entity here and presented in the context of the class 2 major histocompatibility complex on the surface. We've already talked about all of that. Remember, it presents the peptides in the context of class 2 for the T helper cell to recognize. And hydroxychloroquine blocks this process of T cell activation. This is the process that activates the T cells when it sees the antigen that fits its antigen receptor on the surface of its cell. It gets activated and releases cytokines, and it's blocked by hydroxychloroquine. This is why it's very important to give hydroxychloroquine fairly early in the course before the cytokines have been released and cause the lungs to fill with fluid because of a cytokine storm. That's why I mentioned that before. So you can see there's a number of, and I'll stop here. There's a bunch more, but I'll stop here. You've got the gist of this. It certainly inhibits it downregulates the immune response here, and it damages the ability of the virus to replicate itself and to be packaged into new endosomes, which release virus into the interstitial space. Okay, so that's how hydroxychloroquine works. It also works in combination with zinc, which we'll get to in just a second. Here's this slide of how it helps zinc get into the cells. Remember, it's an ionophore. Zinc cannot get in without the help of hydroxychloroquine in this case, okay? It cannot cross the cell membrane. But with the ionophore, it can, and these orange spheres here are zinc. And what they do is they prevent RNA-dependent RNA polymerase from copying the RNA. So that prevents the viral RNA from replicating itself, okay, into all those thousands and thousands of copies which get released by the cells. Zinc prevents that. All right, here's another graphic depicting the same process. You can see the zinc coming up to the chloroquine, hydroxychloroquine ionophore and flipping the zinc into the cell. And you see it does the same thing in this diagram, of course. It's blocking RNA-dependent RNA polymerase from copying itself, okay? This throws a huge monkey wrench into the exponential increase in the number of viruses. Okay, so that's how zinc works. Now, let me talk about ivermectin for a second, because it's in the news and no one's talking about it. It's not approved for use in COVID. But let me talk about what it is approved for use in, and that's as an antiparasitic. But it has very pronounced effects against COVID, according to the Baylor study, and we're going to show that in just a second. Ivermectin has mild side effects, which is a good thing. It has antiviral activity against HIV, simian virus, Zika. As you remember, Zika was the virus that everyone was worried about when the Olympics were occurring in Brazil a couple years ago. A lot of athletes didn't go to Brazil because of Zika virus. It has activity against dengue fever, which is real common in Cambodia. I've even had that, and it is horrible. And very importantly, influenza. Now, these are all RNA viruses, as is coronavirus or SARS-2, okay? A study to measure its effectiveness against coronavirus was done in April of 2020. This is an in vitro study. That means it's done in a lab, in a laboratory setup, not in a person. Okay, that's very important to point out. Sometimes it does not translate from the laboratory to a human study. Chloroquine was done by the National Institutes of Health back in 2003 or 5. I'm not sure. I think it was 5, because SARS-1 came through in 2003. It showed chloroquine was very effective against SARS-1 in an in vitro study. Okay, that's easy to look up. But anyway, ivermectin was tested in April of 2020 in an in vitro study for its effectiveness against SARS-2. And it produced a 50,000-fold decrease in the amount of SARS-2 RNA in 3 days, which is just an enormous decrease. In other words, 99.995% of the initial viral RNA is gone 72 hours after administration. And I'm going to show you the graphs that prove that. Here they are. This is from the study. Now, first, let me just point out that this is a logarithmic scale here. What that means is that the distance on the y-axis between 1 and 10 is the same distance between 10 and 100, which is the same distance between 100 and 1,000, okay? Same distance on the y-axis. If it was linear, there would be 100 times the distance between 10 and 1,000 as there is between 1 and 10. But here, you know, it's twice the distance, okay? People use this kind of a scale, a logarithmic scale, when the reduction is so great they can't fit it on a linear y-axis and fit it on the screen, okay? And let's look at these numbers for a second. It's going to blow your mind. We're talking about relative viral RNA starting out at 100%. After 1 day, it's 0.1%. That means it dropped 99.9% in 1 day. The viral RNA dropped 99.9% in 1 day. And then it goes on to drop another 1/100th of that by the second day. You see that? Same thing here. And here are the graphs that show it. This is cell-associated virus E gene. It's a gene in the RNA. This is relative viral RNA, starts out at 100%. These are the actual data points here, these black dots. And this is the curve that fits that's been fitted to those data points. You can see this is day 1. You can see after day 1, it's down to 0, from 100 to 0. And I just showed you, it goes down not from 100, not just to 0, it goes down to about 10,000%. Pardon me, that's not correctly stated. It goes from 100 down to 1. So that's 1/100th. And then it goes down to 1/10 of that. So that's 1/1000th in 1 day. Okay. And then another 1/100th of that in 2 days. And you can see the same thing happening here. Everything's going to zero here. Okay. Incredibly effective in vitro. Now, I just want to point out how ivermectin works. We're going to get back to that study in just a second, which is very important. But let me just point this out because I've made a point of explaining everything to people as we go along, so you really understand what's going on here. It's not a lot of mumbo jumbo. It can be a little difficult to understand if you haven't studied this, so I try to go over it for each presentation that I do, and I'm sure that by now people are understanding this quite a bit, which is really a great thing. It's important to understand how all these things work that the TV doctors are talking about on CNN and the other networks. Okay, so here's a viral particle, and it's got spike proteins. It's got RNA inside of the capsule. It's got N proteins keeping it stable, and it's got M proteins right there in the capsule determining the radius of curvature, as I said in a previous presentation. Remember, the radius of curvature determines the size of the virus particle, and it must be big enough to contain the RNA, but you want it small so that the spikes are dense on the surface, and as it tumbles through the airway, it's able to increase its efficacy in binding to the ACE2 receptor. You don't want the thing so big that the spike proteins are so sparse on the surface that the chance of it hitting an ACE2 receptor are low. Okay, you want to maximize that if you're the virus. Now, so as we've talked about a few times, the virus binds to the ACE2 receptor with that other protein right next to it, which cleaves the spike and allows the machinery to come out and make the capsule fuse with the cell membrane and deliver its RNA into the cytoplasm of the cell, where it hijacks a ribosome and produces a protein. And the proteins that are produced by that viral RNA include the polymerase, which we talked about being an enzyme which makes nucleotides join together into a polymer. In other words, it copies its RNA. It makes the N proteins, which stabilize the RNA inside the capsule. It makes the M proteins, which determine the radius of curvature, the non-structural proteins, which hijack the endoplasmic reticulum and allow the new virus particles to bud off and then be taken to the cell wall and released into the interstitial space. And it makes a blocker protein. Now, this is the one that's at play in this particular explanation of how ivermectin works. That block protein cannot get into the nucleus. Remember, the nucleus has a wall here also. Oops, all right. It cannot get into the nucleus without a carrier helping it get in there. Now, it binds to the carrier brings it inside the nucleus, it discards the carrier, and it binds to the DNA. Now, on the DNA, there is, and remember, this is the host cell. This is the host cell right here. On the DNA, there is a gene which codes for an antiviral mechanism, okay, to protect the cell. And this blocker protein gets in there and prevents that mechanism from functioning. So think about it. If you prevent an antiviral action from functioning, you're increasing the viability of the virus. And that makes sense because the virus produced this blocker protein. So it's going to help the virus survive by blocking the transcription and then translation into something that is antiviral. Okay, now how does ivermectin fit into this? Well, it binds to the carrier. The ivermectin entity is depicted by this red triangle here. It binds to the carrier and prevents the blocker protein from binding to it. So now the blocker protein can't get inside the cell to do its dirty work, okay? So ivermectin actually increases antiviral activity if you want to look at it that way. Do you understand? Because it's preventing something from getting into the cell, which blocks antiviral activity, Okay, that's how ivermectin works. Now let's go back to the study of the ambulatory patients considered at high risk that are early in their course. The Baylor group studied 320 high-risk patients aged 50 and over with greater than one comorbidity, greater than or equal to one comorbidity that I listed there: chronic kidney disease, cardiovascular disease, obesity, etc., diabetes mellitus. In period 1. In period 2, they added 549 patients. And this, remember, this ended on December 16th, 2020, just a couple weeks ago, a few weeks ago. Their protocol utilized at least 2 agents with antiviral activity against SARS-2, zinc, hydroxychloroquine, and ivermectin, at least 2 of those. Now, they added also 1 antibiotic, either azithromycin, doxycycline, or ceftriaxone. Ceftriaxone is ceftriaxone. It's an antibiotic that we use a lot in surgery as a prophylactic. And it's a cephalosporin, which is a synthetic penicillin, okay? All right. They also had patients that were having trouble breathing with an inhaler and or intramuscular dexamethasone, which has only been proved to help critically ill hospital patients. All right, but the point is, they matched the patients for this, the people that were treated or not treated. Okay. Now, the results just blew me away when I saw this. In period 1, which went on from April to September, which is 4 months ago, 6 out of 320 patients, and well, let me just talk about the ones, the reduction in hospitalization first. In this study, 6 out of the 320 patients, which is 1.9%, were hospitalized. And according to the Cleveland Clinic, it has a calculator for the likelihood of hospitalization given the comorbidity status and the age. For that group of patients with at least one comorbidity over 50, according to Cleveland Clinic, there should be an 18.5% hospitalization rate. But in the study, given hydroxychloroquine and zinc or ivermectin and the nutraceuticals and the antibiotics and so forth that I just listed, only 1.9% went to the hospital of that ambulatory group. Now that's an enormous reduction, okay? Now, here's another thing that'll blow you away. Only 1 person out of 320 died in period 1. Okay, just hang on to that idea for a second. In period 2, which again ended on December 16th, only 2.6% of patients went to the hospital after being treated by that protocol. And again, the Cleveland Clinic expected 18.5% of them to go to the hospital. And only 1 out of 549 died. 1 patient out of 549. Now, you may be saying, well, wait a minute, haven't you been telling us this whole time that COVID's infection fatality rate is equal to the flu, about 1 in 1,000? Yes, but that's all infected people. That's not high-risk patients with a comorbidity that are over 50 years old, okay? That group should have a much, much higher fatality rate, okay? But look, it's 1 in 549. That's very, very low for that group. And I'm going to give you the proof in just a second. But look at this. Think about this for a second. This protocol was extremely effective, I would say. Okay? Now, not only in reducing hospitalization, but also in reducing death. So here are the numbers. This is a direct quote from the paper, from the abstract of the paper. Our early ambulatory treatment regimen, remember, early in the course of the disease, was associated with an 87.6% reduction in hospitalization. It's almost a 90% reduction. That means 10 people that would have gone to the hospital before, only 1 of them goes now with this treatment. and a 74.9% reduction in death. Think about what a 75%, 74.9 or 75% reduction in death means. That means for 400, we're nearing 400,000 deaths from COVID, according to the mainstream media. Now, there's a lot of problems with that because they're using the PCR test, which I've gone over many times and explained that it's a horrible test to determine new cases of the virus because it tests for RNA, not viable virus. And they're going to call something a new case that has a positive PCR test, even though RNA is present in the mucus in the nasopharynx months after you've recovered from the disease, and they're calling that a new case, which is causing enormous inflation in cases, hospitalizations, and deaths. But given all that, given the system that they're using to assign deaths, hospitalizations, and cases to COVID, there's a 75% reduction in deaths. That means of the 400,000 people that they say have died from COVID so far, 300,000 of them is 75%. So with a 75% reduction in these older patients, high risk, that you could have treated early on with this medicine, we could have eliminated 75% of the deaths. Okay, I think that's pretty clear. Conclusion, we conclude that early ambulatory multi-drug therapy is associated with substantial reductions in hospitalization and death compared to available rates in the community. Remember, compared to what the Cleveland Clinic says is the rate of hospitalization and death that you would expect for those patients over 50 with at least one comorbidity. Prompt ambulatory treatment should be offered to high-risk patients with COVID-19 instead of just watching them and sending them home until they have trouble and you bring them into the hospital later in the course of the disease and try to salvage them. These patients all should be treated with these triple antibiotic therapies, okay? Either hydroxychloroquine, zinc, and azithromycin, or ivermectin and its group. Now, according to the study, okay, it was done at a very renowned university, Baylor in Dallas, and so forth. And you're welcome to go back and look at the protocol and who did the study and look it up. It was Dr. Proctor's group. I'm just reporting on the study, but it is completely contradictory to what was said the entire spring and summer about hydroxychloroquine and zinc. And the studies that they used to say that it did not work were flawed in a very substantial way by giving way too high a dose of hydroxychloroquine, not including zinc, and doing it in hospital patients that were already sick, that had already had fluid in their lungs from the cytokine storm or whatever caused it. You got to catch the patients early to downregulate the immune system while you're also blocking the virus's ability to replicate and be released by the cell, okay? Here it is graphically. An 87.6% reduction in hospitalization here. This is, again, is what's predicted by the Cleveland Clinic formula. And this is the reduction in death, 74.9% reduction in death. That's removing 300,000 from 400,000 deaths. That's what a 75% reduction means. Okay. Now, to be complete, I decided to show how Rim Desevere works. Rim Desevere was a drug that was used for a little while. It was later proved not to work, but it was a new drug. Everybody was all excited about it, and it was very expensive. It cost, depending on which reference you use, from about $3,000 per course to up to about $6,000 per course. And I think that depends on what kind of insurance the patients have, maybe, whether it's Medicaid, Medicare, or private insurance. But I just used $5,080 because that was quoted a number of times per course, $5,080. whereas hydroxychloroquine and zinc cost $20 and ivermectin costs $17.14. So it's much more expensive than these other treatments that I've just presented the study on. So let's look at how Rim Desevere works. It's been proven since then not to work, but it was believed to work at the beginning and got emergency release by the FDA. So let's look at this for a second. Now, the way you can tell how this thing works, it's very simple, really. You don't have to understand chemistry or anything. Just look at this picture of the Rim Desevere formula here, which has, you know, the, let me put my glasses on so I don't do something wrong here. It has this ring here with the 3 nitrogens on it, just like the nucleoside triphosphate, which is going to be inserted into the replication process up here. Remember, the polymerase takes nucleotides and it assembles them into a copied RNA molecule, okay? Now, look at this moiety right here. It's got an NH2 group here, like this. It's got the ring with the nitrogens on it. It's got another ring here of the carbons with 1 nitrogen on it, a pentamer. Then it goes down here and it has another 5-sided figure, which is a pentamer with an oxygen there. OH, HO, OH, HO. Okay, they're similar, aren't they? Very similar. So basically the idea behind Rim Desevere is that it's going to trick this process into being incorporated into the new copy of the RNA by RNA-dependent RNA polymerase. We've talked about this a lot, how it copies itself. All right. Now, when the Rim Desevere gets into the cell, it has to go through a number of conversions before it gets to the proper form to trick the RNA-dependent RNA polymerase. And let me just show you this sort of graphically here. The natural nucleotides are depicted in yellow and blue. And you can see, you know, everything's going along normally. It's putting a yellow with a blue and a yellow with a blue and a yellow with a blue. And all of a sudden it gets tricked by the converted Rim Desevere and it puts a red one in. Okay, that's depicted, Rim Desevere's converted metabolite is depicted by a red square there. And it puts a red square in, which messes up this piece of RNA here. It's not correct. And it leads to delayed chain termination, okay? That's how it blocks the replication of RNA. Oops, sorry. That's how it blocks the replication of RNA, but it doesn't work. Okay? So, wow, this medicine, which sort of displaced the other ones as effective in SARS-2, it turns out doesn't work, and it was incredibly expensive. And according to this study, hydroxychloroquine, ivermectin, and so forth do work, according to this study. Now, there may be more studies that come out, but I sure want to see them designed properly. The ones I found all over the internet, I'm talking dozens and dozens, including the 6 that were cited by the TV doctors and the anchors, were not designed properly. Again, for the final time, I'll tell you, they used too high of a dose of hydroxychloroquine, some of them. They did it in hospitalized patients. That's the wrong group, some of which were very ill, had already had the cytokine storms and so forth. They did not use zinc. Zinc is very important, as you saw in its mechanism of action and in the results that were achieved by both the NYU Grossman School of Medicine study for hospitalized patients and the Baylor Medical Center study for ambulatory patients early in the course that were high risk at over 50 years of age with one comorbidity. Thank you very much for hanging in there with me. I found this very interesting to find these studies that were actually designed properly, and I hope you did too. Again, please visit my Patreon page and consider becoming a patron if you'd like to. I'd appreciate it very much. let me just say one last thing in terms of a word of warning. Don't go out to the pharmacy and get a bottle of zinc and start gobbling it down. Talk to your doctor first, make sure he knows everything that you're taking for this. And the reason is, if you take too much zinc, you can block the uptake of copper. They're both ions that are charged 2+. And if you have a copper deficiency, you can become very, very ill. So don't do that. Make sure that your doctor knows what you're doing. As with any medicine that you would take, always consult your personal doctor. I'm here to help people understand this and to present studies to them that sometimes contradict the experts. As has been sort of my charge since the beginning of this, with the infection fatality rate, the need to close schools, the absurdity of the lockdowns, given that the virus is nanoscopic and you think you can stay at home and not have the virus come into your house. It goes right between the cracks of the door. Okay, I'll leave that alone. I've talked about that a lot already. Even mask use, where I presented 72 years of randomized controlled trials that showed that masks don't reduce transmission. Even the one randomized controlled trial this year, the Denmark study, also showed that there was no significant difference between mask wearers and people who did not wear masks. So that's been my charge, and I'm trying to be as objective as I can. I have no skin in the game at all, but I do want people to be informed of the truth in science. And thank you for watching, and I'll see you down the road.